In this part of the question, we're asked if the two runners ever passed each other during the race. This is equivalent to asking if the x position of Steve was ever equal to the x position of Olga, as it must be when they pass each other. To answer this question, we're going to need to understand unit conversions and how to use kinematic equations. We are told that Steve runs the marathon at a constant pace of 9 minutes per mile. The first step is to convert his pace from units of minutes per mile into a velocity of units meters per second. We do so by converting miles to kilometers, kilometers to meters, and minutes into seconds. Multiplying through, we find that Steve runs the marathon at a constant velocity of 2.96 meters per second. Now that we know the velocity at which Steve is running, we can figure out the time at which a pass would occur. The pass occurs when the x position of Steve is equal to the x position of Olga. To figure out if this occurred at a given time, we write a kinematic equation for the position of Steve involving velocity and time, and a kinematic equation for Olga involving acceleration and time, because we're told that Olga runs at a constant acceleration of 4.8 times 10 to the minus 4. We solve this equation for t, and we find that the time at which the pass occurred is equal to 2 times the velocity at which Steve runs divided by Olga's acceleration. To figure out the position at which the pass occurred, we can now either use the kinematic equation we wrote for Steve or the kinematic equation we wrote for Olga. Here we choose to use the one for Steve. We substitute in the expression for the time we just calculated and evaluate it using the quantities that we know. We find that the pass occurred at 36.5 kilometers from the start line. Because this distance is less than the distance of a marathon, which is 42.2 kilometers, the two runners did pass each other during the race.